Hey, how y'all doing? I'm gonna go ahead and record my problem number two, homework number four talk through. I'm not gonna lie, man, I kind of carried the team on this one, but I'm gonna go ahead and talk about it anyway because I kind of get it from 502, but also at the same time, like I'm not gonna lie, a lot of the Hamilton stuff to me just kind of seems like we're well, especially problem number two is just like following instructions. Problem number one, Linda and all that comment section really helped me through it. I'm definitely going to review this some more, but as it is due tomorrow, I'm going to go ahead and just upload a video of me talking about things I did or did not understand. Maybe it'll help somebody, maybe it won't. We'll see. All right. I think this button, like an old man trying to share my screen. Somewhere in here. I'm gonna go ahead and share this. I think this will take us the right spot. Looks pretty right to me. All right, sick. Gosh, I hate how much stuff Zoom puts on your screen. All right. Wolf got big headache. Just sorry. Um, alrighty. So deriving the I'm I can read my handwriting, but I'm stuttering. I'm telling you for the system in terms of QP, B in the usual way, you should find that blank. When I had to find the coordinate system and positional vectors, there's only one, just like N1 here, going over to the right. From there, I was able to get position, velocity, apply this equation, apply the spring equation, apply the constants that Gary gave us, and there's my answer. I wrote it both in the style that made sense the most to me, as well as the style that Gary suggested, or Dr. Mav, sorry. Um, B and C kind of go together. I wrote this here as a joke, just saying that I chose the following. We're calling them generating functions, but we always call these forcing functions. From there, just taking the partial derivatives of the forcing function. Got this set answer. It's pretty straightforward. Here, expansion for pre-solve for QP, and then substitute this expression. Find P, Q, comma P. Went ahead and subbed subtracting. Sure. Crazy. Yeah, I'm not going crazy. All right, I went ahead and utilized this to basically solve for the Q component and then plug that said Q component back into the original P equation. So now we have one defined as P and the other one defined relative to Q. And then here, then further for the H prime Q of P, just went ahead, plug these two into the original H equation, and just took the derivative, canceled out using trig identity here, and just dividing 1/w divided by the second. And then this is the answer I got for part E. From there, took partial derivatives relative to P, Q, H with a little only next to it. That's not what you would call that, but the derivative of H got these two set equations. And then from there, basically integrated both of them, got constants, which would vary depending on your initial conditions. We weren't given any, so I solved for the constants. And then after plugging these back into P and Q equations, I came up with a P of T and a Q of T equations. If you have any questions, feel free to comment on, but I thought this problem was pretty straightforward. I was not gonna begin to talk about problem one. Again, Linda and several other people really helped out on that one. I hope everybody has a good weekend and good luck on the exam.